Okay, welcome back. What I want to look at today is mathematics in reference to complex numbers multiplication. Okay, now consider the product of two complex numbers in brackets 3 plus j square. I'll call it j square. Okay, and in brackets 4 plus j. Now the brackets are treated in the same way as the rules of algebra, such that you will follow the multiplication ruling. Okay, and what I've done here, I've marked it as 1, first multiplication, 2, second multiplication, 3, third multiplication, and so forth, fourth multiplication. Okay, to get it out of the bracket, so we need to take it out of the bracket first. Okay, and when I've done that, you can see my result here. Now remember, you have to find your own style of learning. You have to interpret this for yourself. Okay, you have to make sure that you can understand. So when you're looking at this, write it out, put pen to paper. I can't tell you that enough. Okay, pen to paper, it always works. Now z1 equals 3 plus j squared, z2 equals 4 plus j, and you can see it was all from our original formulae. Okay, z1 and z2, a plus b brackets, c plus d in brackets. Okay, now again, make sure that you're following the principle and you're following the rules as laid down. Check the rules for yourself. It is important that you do a bit of work for yourself to make sure that you can understand what is being said here. Okay, how I have approached it is slightly different to how you might approach it. Okay, please remember that you will have your own style of learning. Okay, use it. Okay, now here we're just simply using a similar example in regard to this. If this is let me just check what I've looked at just now. Okay, yeah. Now we refer to the dot as an AND function, and okay, rather than saying and so forth again. Okay, we put it in the text. Okay. Now multiplication. Now you can see that here, all I've done here is to, where was my question? You can see that my question is here. I've used this, okay? Okay. Okay, here we've multiplied out the brackets, okay? But here we're looking at multiplication in this form. And here you can see I've multiplied it out. Now this multiplication comes from this combination here, okay? Comes from this combination here. So here you multiply it out, okay, in full. I'm not going to go through that with you. That's something you can do for yourselves now. And as I've said to you, put pen to paper, okay? And here we're still looking at complex numbers, okay? And remember that j squared equals minus 1, okay? That's what this is saying, okay? So multiplication, observe usual rules for multiplication, and remember j squared equals minus 1, okay? Okay. So I'm just trying to make sure that it comes up good on camera and it can be seen, okay? That's what I'm trying to look at the moment, okay? But okay. 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 Now here we're, as I said, we're looking at multiplication. Observe usual rules for multiplication and remember j squared equals minus 1. Okay, here I've put down a calculations, z1, z2 equal, etc. Okay, we have an AND function here and we proceeded to multiply out the brackets, okay? And that's for you to do yourselves, okay? I won't be doing that for you, okay? Alright, as I've done the hard work already. And here we have looking at square roots of complex numbers, okay? If z1 equals r, I call this theta, okay? It represents the angle. Then z2 equals r square 2 theta, okay? I call it theta, you call it what you like, but it represents the angle, okay? Now r times r times theta times theta. Now I've done this basically for my own reference. It's just my way of trying to remind me that I'm actually multiplying, that is represented by a square, r square. Okay, so remind me that is what I'm doing. Okay, so we expect z equals r square root of theta over 2. Okay, and well, I would refer to this as polar Cartesian form. Okay, this is 1 square root 1 of 2. Okay, now remember that I'm trying to look at this from a different perspective, and I'm trying to explain it to you as to the process that I've applied. But you've actually got to do this for yourself in order that your brain understands the structure and what is required from you. Okay, to get the other square roots, we remember that we can add multiples of 360 degrees to theta without changing z, i.e. z is also given by r equals z equals r theta plus 360, from which z square root of z can be obtained equals r theta over 2 plus 180. So it's just a different way of looking at the same thing. The square root of complex numbers, example. Now here, find the square root of z equals 2 minus j5. Convert to polar form. Okay, z equals 2 minus j5. In polar form, it'll be 5.385 minus 68.2 degrees. Now, I'm going to leave you to do that for yourselves, okay? How did I get that? You work that out. That should be interesting. I'm an old man now. Don't need to be working so hard. Apply rules of square roots, okay? Okay, etc. Minus 68.2 over 2, okay? Excuse me, sorry about that, okay. That then brings us down to 2.320 minus 34.1 degree, okay? And or minus 34.1 degree plus 180. And that's just an OR function, of course. An AND function, I should say. And of course 2.320, 145.9 degrees. Now, I'm not going to go for this because you have got to find your own method of sorting it out and bring it into play in regards to polar and Cartesian. Okay, I mean, these mathematical formulas that have been developed over time, it's amazing. And again, here we have another example, okay? Z equals 2.36 minus j1.32. Find z square and the two square roots of z in a plus jb form. Z1 squared. And here you have the formula that we need to bring into play of multiplying. Okay, here we have our solution here, 3.827 minus j 6.23. Convert to polar. and when you convert it to polar form, it becomes 7.312. Now you need to know how to convert to polar form. Okay, you would need to know how to convert to polar form, so that's something you'll need to learn and know yourself. Do your own groundwork so that your method of converting to polar form is your method of finding that solution. Okay, this is mine. Okay, I've, did I? You can see what I've done here. That I went through that lengthy, long-winded process. It's only for my style of learning that I do this, but I hope that you guys might find it useful as well. Okay, square root. Okay, am I? Okay, and here we are. Okay. Now be sure you know what form you're working in, whether it's Cartesian or polar. Okay. And here's our result. Okay. Now, one of the things here, even though this is my work, I've left out certain bits of it actually, showing how to actually convert the numbers. It's on your computer. It's on your phone. It's on your calculator. It's on your calculator. You punch it into your calculator and you bring it up. Okay. But you need to know what the calculator does to get that function, to get that solution, and that is the part that has always bewildered me, in a sense that I think it's important, but some of you guys think that just type into the calculator and the calculator will do it for you. The fact is that you need to know how to do it for yourself. That's the thing. And here we have again some further square root of complex numbers. Okay, and again all I'm doing here now is showing you the process of multiplying it out and what we come up with. Now this is just me putting it in a manner so that I can interpret it correctly for myself. And you can see what happened here, can you? That all the J's functions are brought to one side, and those numerical numbers are brought to the other side. And you can then see here, so that by bringing this into play here, 4 minus 25 leaves you with minus 21. And in my mind, I would love to have brought this around and say 4 from 25 leaves me 21, me bringing this as a positive function. But why can't I do that? It's okay, it's just something that I ask myself. Then the answer here will not be right. But can't we not have a positive and negative function in those Cartesian and polar form? It's okay, just a question I'm asking myself, just a question. I expect somebody more brighter than myself will give me a answer to that. Thank you. Now here we are again, mathematics square roots of complex numbers still, and this is just showing you how from this function here to how we get to this function here. Okay, and I've worked that out for myself. Now feel free to disagree with my process. Okay, that's what it's about. I'm not saying that I'm perfect, but I'm just looking at it from my perspective. Okay, and I hope that some people find my perspective useful. Yeah. Okay. That's good. Okay. Now here we have to convert to polar form. Okay. And when you look at polar form on your calculator, it'll give you a given function for that. But I still like to know how to convert it by hand, because nothing better than knowing how the calculator has arrived at its solution, the process it went through to get there, and that is what matters. Okay. Again, still on square root, and complex numbers. Okay. Sorry about that. Okay, so asking you to convert back to polar form. Okay. And you can see that's where we're at. Now remember that you will need your calculator to do some of this work, but do not rely on the calculator itself. You need to know how to put it in. Look at engineering mathematics books as well. That gives you a lot of idea. Look at Gearing or something, some guy like that, but who wrote a very useful math book that I've used over the years. Okay. If it's the wrong name, I apologize before now. Okay. Now we're looking at 4 division. Okay. Now I'll tell you something now. I have to admit, it's a while since I've done calculus and polar forms. And when I did this, I was hot on it. I was hot, man. I was hot. Looking at it now, I'm just trying to remember in my mind. Goodness me, what did I do to get that there, get the figure there? Strange. I hope you guys do better than me, but I'm excusable. My age now, you see, so. Okay, I hope you found this useful. Okay, Z1, Z2, you have your values here. Okay. Uh, mhm. Now be sure you know when you're in Cartesian or polar form. Okay. I'm not going to try and remember or remind you of this here. That's something you'll need to know. Me, I'm here now, and I'm just trying to make sure that I get all of it in place. So let me just recap. Okay, I'm just going to go back and recap, make sure that it's all in view. Okay. I'm quite pleased with this bit of work actually, because you see here when it says convert to polar form, I mean I've just done this automatically, you know, but you need to know how to do that for yourself, okay, and apply that process of learning. You just try to make sure that everything is in view, okay, and that I haven't okay. Thank you. Hope you found this useful. Have a good day. Bye bye.